Welcome everyone. Today, we're diving into a really fundamental chapter for your NEET UG physics prep, units and measurements. Trust me, getting this right builds a super strong foundation for everything else. So, let's get straight into it.
Hello, NEET aspirants. This explainer is designed just for you. We're going to focus laser sharp on the concepts from this chapter that show up again and again on the exam, the ones that can seriously boost your score.
So, here's our game plan. First, we'll tackle how to derive units for some key constants. Then, we'll get our hands dirty with measurement instruments and, the errors that come with them. After that, I'll show you a powerful problem-solving trick using dimensional analysis, and we'll wrap everything up with a quick, high-impact revision sheet.
First up, deriving units and constants. Look, mastering this is it's not optional. Why? Because if you really get a handle on units, you understand the deep relationships between physical quantities, and that is the absolute key to solving a ton of problems. Let's kick things off with thermal conductivity, which we call K. All this tells you is how well a material can conduct heat. The formula you got to know is for the rate of heat flow, or dQ over dt. It's equal to K times the area A times the temperature difference, delta T, all divided by the length L. So how do we actually find the unit for K? It's pretty straightforward. First, you just do a little algebra to get K all by itself, easy enough. Next, you plug in the SI units for every single variable. So, watts for power, meters for length, meters squared for area, and Kelvin for temperature. You'll see 1 meter on top cancels with 1 on the bottom. A quick cleanup, and there you have it, watt per meter Kelvin.
Okay, let's use that exact same thinking for another big one, the permittivity of free space, or epsilon naught. This thing is literally the foundation of electromagnetism, and of course, it shows up right in Coulomb's law, which tells us the force between two charges.
And you guessed it, the process is exactly the same. First, we isolate epsilon naught. Quick pro tip, that 4 pi is just a number. It has no dimensions, so you can just ignore it for this. Then, we plug in the units for everything else. Coulombs for charge, newtons for force, and meters for distance. And that leaves us with our final unit, Coulomb squared per Newton meter squared. See? Not so bad.
Okay, let's move from the world of pure theory into the lab. Welcome to Section 2, Instruments and Measurement Errors. Because remember, in physics, how you measure something is every bit as important as what you're measuring. Think of this as your personal screw gauge cheat sheet. You have got to know these 3 formulas cold. There's one for the least count. That's the tiniest measurement the tool can possibly make. Then one for pitch. And of course, the big one, the measured diameter, which combines the main scale reading, the circular scale reading, and corrects for any zero error.
Let's put this into practice with a classic NEET-style problem. Okay, so first step, we calculate our least count. That comes out to 0.01 millimeters. Now we just use our main formula. We plug in the values, the main scale reading is 0, and we add the circular scale reading of 52 times our least count. That gives us 0.52 millimeters. And finally, a quick conversion gives us the answer they want, 0.052 centimeters.
Let's be real for a second. No measurement is ever perfect. So, what happens when you have to combine a bunch of these imperfect measurements to calculate something else?
Well, that brings us to error propagation. And here is the single most important rule you need to burn into your brain. Errors always add up. They accumulate. Look at that formula. The powers of the variables like x, y, and z, they just become multipliers for the errors. And this is super important. Even if a variable is in the denominator, you still add its error. Errors never, ever cancel each other out.
All right, here's a perfect example from NEET 2013. We need to find the total percentage error in P, which depends on A, B, C, and D. And as you can see, they've given us the percentage error for each one of those measurements.
So let's just use our rule. The power of A is 3, so we take 3 times, it's 1% error. The power of B is 2, so that's 2 times, it's 2% error. And C and D are just to the power of 1, so we just add their errors straight up. Now we just plug in the numbers, do some quick addition, and bam, there's our answer. A massive 14% total error. This is such a great example of how tiny little errors in your measurements can snowball into a really big uncertainty in your final answer.
Now for our third section, which I honestly think of as the secret weapon for physics problems, the power of dimensions. This is a technique that can save you so much time and help you catch mistakes.
So let me ask you this.
How can you quickly check if a formula even makes sense? Or maybe find a relationship between two things without doing a bunch of heavy calculations? Well, the answer is dimensional analysis. And the whole thing is built on one simple, beautiful idea, the principle of homogeneity. All this means is that in any real physics equation, the dimensions on the left side have to exactly match the dimensions on the right. It's like the apples and oranges rule. You just can't add meters to kilograms. It doesn't make any sense. So check this out. What on earth could energy density possibly have in common with Young's modulus? They seem totally unrelated, right? Well, let's just look at their dimensions. When we break them down to their basic mass, length, and time components, look at that. They both simplify to ml to the -1 t to the -2. They're dimensional twins. This is a classic question they love to ask on the NEET.
Dimensional analysis can also be a really cool way to think outside the box. So imagine a different universe where force, velocity, and time are the fundamental building blocks, not mass, length, and time. How would you write the dimension for mass? Well, you can figure it out. Just start with an equation you already know, like F equals ma. Rearrange it to solve for m, and then just express it using the new fundamental units. And you find that in this system, mass has the dimensions of F to the 1, V to the -1, T to the 1.
All right, we've covered a ton of ground, so let's wrap it all up in our final section, the NEET Quick Revision. You are definitely going to want to screenshot this next slide. This right here is your high-yield summary. I've put together 5 of the most important quantities you will see over and over: stress, the gravitational constant g, Planck's constant, resistance, and surface tension. Your job is to memorize their key formulas and especially their dimensional formulas. This is pure gold for your last-minute study. If you found this breakdown helpful and you like this visual, step-by-step way of learning NEET concepts, please show your support and hit that like button, drop a comment, and subscribe for more. And I'll leave you with a little challenge. Which one of these dimensional tricks we talked about today are you going to actively try to use to save time in your next mock test? Think about it, because using it could be the difference maker. Good luck, and keep up the amazing work.